Welcome dear students and all the viewers. Now in today's video lecture we are going to study program number 4 of our microprocessor and microcontroller laboratory. Program number 4 is the software program or the non-interfacing program. What we have to do is we have to design and develop an assembly language program to compute nCr of a number. And that too using recursive procedure, and we have to assume that both n and r are non-negative integers. Now you all are well aware of the fact that what nCr is. In mathematics, combination or nCr is the method of selection of r objects from a set of n objects where the order of selection does not matter. In order to compute nCr of a number, we should make use of the following formula. Now you can see here, what I will do is I will show you the mathematical steps. In order to compute nCr, we should make use of the formula n factorial divided by r factorial n minus r factorial. So in order to compute nCr of a given number, we should make use of this particular formula, that is n factorial, r factorial, n minus r factorial. Here three different sets of conditions are there. Condition 1 I will explain you first. Condition 1. In condition 1, if r is equal to 0, if r equal to 0 or n equal to r, then nCr will be equal to 1. Now to understand condition 1, what I will do is I will assume n value equal to 5 and r value equal to 0, and I will substitute these values of n and r in the formula for nCr to compute nCr. So you can see here phi c of 0 will be equal to n value is what? 5 factorial, n value is 5 factorial, then r is 0, so it will be 0 factorial, and n minus r, it means 5 minus 0 factorial. So we'll see here 5 factorial, how we'll write? 5 into 4 into 3 into 2 into 1. Now in the denominator you can see that 0 factorial value always it will be equal to 1. Then into, again 5 minus 0 is what? 5 only. So 5 factorial, again I have to write 5 factorial will be what? 5 into 4 into 3 into 2 into 1. So if I see that, this will be what? 5 into 4 is 20, 20 into 3 is 60, 60 into 2 is 120, 120 into 1 is 120 divided by, again this will be same number, 120 into 1 will be 120. So what we'll get? We will get the answer as equal to 1. So phi c of 0 we are getting as 1. It means that when r equal to 0, then nCr will always equal to 1. Now in the other condition, in the other set, that is n equal to r, will assume n equal to r means already n we have taken as 5, then r will also be equal to 5. R will also be equal to 5 since n equal to r we are taking. So what we'll get now? Phi c phi is equal to, n is what? 5, so it will be 5 factorial divided by, then r is again 5 factorial, then 5 minus n minus r, 5 minus 5 factorial. So 5 factorial, how will write? 5 into 4 into 3 into 2 into 1 divided by, again 5 into 4 into 3 into 2 into 1. The value for 5 factorial I have written 5 minus 5 will be what? 0. 0 factorial is what? 1. 0 factorial is always equal to what? 1. Again, if you see that, if we compute this, if we calculate this, again we'll get the value as 1. So phi C phi is equal to 1. Thus, in condition 1, if you see, if r equal to 0 or n equal to r, the nCr will be always equal to 1. Condition 2 I will explain to you all. Condition 2. In condition 2, if r equal to 1 or r equal to n minus 1, then nCr will be equal to n. nCr will be equal to 1. So now we'll see this. We will assume n as phi. A random number I am taking, n as phi. Now we all know that in order to compute nCr of a number, we are having the formula n factorial divided by r factorial n minus r factorial. This formula we are having. So first what I will do is, I will consider r as 1. What I will do? I am considering r as 1. So I will substitute here. Phi C1 is equal to, n value is what? Phi. So phi factorial divided by r is what? 1. So 1 factorial into n is what? Phi minus 1 factorial. So I will write as phi factorial. How we can write? Phi into 4 into 3 into 2 into 1 divided by 1 factorial is 1 into phi minus 1 is what? 4. So 4 factorial, how we will write? 4 into 3 into 2 into 1 as phi minus 1 factorial is equal to what? 4 factorial. So I have written here 4 factorial values. So you can see that ultimately this get cancels. So what will get? Phi. The final result will get as what? Phi. So you have seen that when r equal to 1, the value of nCr we are getting as equivalent to n. As n equal to 5 we have assumed, here also we got phi. So in the other set of condition, that is r equal to n minus 1. R equal to what? N minus 1. Here I will show you. R equal to n minus 1. Here n is what? N is phi. So r will be equal to phi minus 1. So r is nothing but 4. Now again this value we will compute in the formula for nCr. N is phi and r is 4. So phi C4 will be equal to phi factorial divided by n value is 5. So 5 factorial. R value is 4. 4 factorial. Then n minus r. N minus r, very carefully I will compute. N is 5 and r is what? 4. R is 4 factorial. So here you can see that 5 factorial, how we are going to write? 5 into 4 into 3 into 2 into 1 divided by 4 factorial is 4 into 3 into 2 into 1 and into 5 minus 4 is nothing but 1 factorial. So this value will be what? 1. Now if we calculate, 5 into 4 is how much? 20. 20 into 3 is 60. 60 into 2 is 120. 120 to 1 is 120 divided by 4 into 3 is 12. 12 into 2 is 24. 24 into 1 into 1 is 24. So if we divide this, we will get the answer as equal to 5. The answer is equal to 5. 24, 5, 0 will be 5. Condition 3 I am going to explain you. The last condition is condition 3. In condition 3, we are going to define the recursive definition of nCr. The recursive definition of nCr is computed as nCr is equal to n minus 1 CR plus n minus 1 C of R minus 1. So the recursive of definition of nCr is computed as nCr is equal to n minus 1 CR plus n minus 1 C into R minus 1. So now what we'll do is, in order to use this recursive definition of nCr, we are again going to assume the values of n and r. So what I will do is, I will assume n value equal to 5 and r value equal to 2. What I am doing, I am assuming n value equal to 5 and r value equal to 2. So here 5 C2 will be equal to n minus 1, means 5 minus 1 C of r value is 2, C of 2 plus n minus 1, 5 minus 1 C of r minus 1. R minus 1 is nothing but 2 minus 1. So what we will get? We will get 5 minus 1 is 4, 4C2 plus 5 minus 1 is again 4 C, 2 minus 1 is what? 1. So first we will compute 4C2. 4C2 means here ultimately this will be n, this will be r. So here you can see that in order to compute 4C2, I will write as 4 factorial divided by 2 factorial n minus r, that is 4 minus 2 factorial, plus here you can see that 4C1, 4 factorial divided by r is what? 1 factorial into 4 minus 1 factorial. So 4 factorial, how we are going to write? 4 into 3 into 2 into 1 divided by 2 factorial is nothing but 2 into 1 and 4 minus 2 is again what? 2 factorial. 2 factorial is again 2 into 1. So if I compute this, first I will calculate this also. 4 factorial will be 4 into 3 into 2 into 1 divided by 1 factorial is nothing but 1 into 4 minus 1 factorial will be what? 3 factorial. 3 factorial, how we are going to write? 3 into 2 into 1. So here you can see that 4 into 3 is what? 12. 12 into 2 is what? 24. 24 into 1 is what? 24 divided by 2 ones are 2, 2 ones are 2. 2 into 2 will be what? 4. Plus here you can see that 4 into 3 is what? 12. 12 into 2 is 24. 24 into 1 is again 24 divided by 1 into 3 into 2 into 1 means this will be ultimately 6. So 4 ones are 4 6 are plus 6 ones are 6 fours are. So 6 plus 4 will be equal to 10. So ultimately the nCr of 5C2 should be equal to 10. After all the three conditions, now we will see the next steps. So we will go to start, then run cmd OK, then we will type the required commands in order to get the editor window. cd / enter, then cd tasm. tasm is a turbo assembler which we are using for non-interfacing programs or the software programs. Enter. In order to get the editor window, I need to type the command edit program name. Now a suitable program name I will give nCr4, as it is my fourth program. So I will give nCr4 followed by the file extension .asm. Now I will press enter. In order to get last screen, alt enter. So here I have to type the required code. So I have typed the required assembly language program. Now I will save it, alt F, and I will save it. After saving the program, what we have to do is we have to assemble, link and run the program. Type the command, first alt Fx, then tasm /l/zi. My program name is what? ncr4.asm. Then I will press enter. You can see that there are no error messages and no warning messages. It means that our program is error free. The next step is plink/v program name. My program name is ncr4 and I will press enter. Then final command is program name. Just we have to type program name, enter. Sorry, td I have to give. I have missed td, program name ncr4, enter. Now here what I have to do is I have to enter the watches over here. It means that the n value and r value I have to give here. In order to give that n and r values, I will type Control F7. Now just I will enter n. I will enter n. Enter. Then again I will type Control F7 and I will type r. Enter. Again I will type Control F7 and I will type nCr. Since we are computing nCr, I will press enter. Now you can see that in order to compute the nCr of 5 and 2, our output should be 10. So in order to get that, I will press F9. So now you can see that the nCr of 5 and 2 is, the combination 5C2 is 10. So I hope this output is clear for you all. Now I am ending the session here. Thank you.